All right, so we are doing lesson 7.1 today, which is on ratios and proportions. And actually, guys, unit 7 is one that we as geometry students usually do a really good job with. So if you're like, I was having a hard time with special segments, there were so many rules for quadrilaterals that I couldn't keep it straight. Hopefully this is like going to be a unit that like really works for us. So proportions and ratios is where we're starting. So first thing we got to do is a little bit of vocab. So ratio is the quotient. Remember that quotient refers to division or dividing. So we're doing division with A over B. And B cannot be 0. So we have to make sure that B is an actual number that's not 0. And A and B are two quantities measured in the same units. So it can't be like hours over minutes. Like that doesn't count as a proportion. It needs to be like hours over hours or minutes over minutes or feet over feet. So whatever the numbers are should be the same unit on both top and bottom, or else we can't compare it. You've heard this comparing apples and oranges. Oh, there's Jackson. Heard the phrase comparing apples to oranges, right? Or you can't do that. Like there's no comparison to that, but I can compare apples to apples because they're both the same thing. So I have to make sure I'm in the same unit here. Another thing to make note of is that we can express it as a fraction of like A over B, or as a, like with a colon, A to B. Let's use actual numbers for this. I don't know about you, but sometimes I get all bent out of shape with the colons. And so I got to make sure that I know exactly what I'm talking about. A fraction that like we know and do a lot is 1/2, right? So if I had like, instead of A over B, what if I wrote it as like 1 over 2? We're used to seeing that. But then when you see it as a colon or as a like ratio written sideways, we would just say 1 to 2. So if you would rather write it as a fraction, you can do that. If you'd rather write it with the colon as a ratio, you can write that. Either way, up to you. Both mean the same thing. The other thing is that there are no labels when it comes to ratios. I know that like I just said that they have to have the same unit, so it needs to be hours over hours. Well, because it's the same unit, we don't need to label it as like hours over hours. So there will be no labels needed. We just like assume that we know that we're talking about the same thing. Okay, so that's all that we have to know about ratios. Now we had to do ratios before we did proportions because proportions are made up of ratios. So a proportion is an equation. Ooh, I meant to do this. It's an equation that relates to ratios. So it's made up of two ratios set equal to each other. A over B equals C over D. So I've got an equal sign. I've got one ratio equals another one. Now we're actually going to do this more in a little bit, but I'll bring it up now because I'm sure most of us recognize it. When we see something like this, we immediately draw that X and then we kind of are like, ooh, I'm not really sure what to do. That means that we're going to cross multiply. And again, we'll talk more in depth about this in a little bit. The reason we're allowed to cross multiply is because there's that equal sign there. So with that equal sign, we are going to cross multiply and multiply the A and the D and then B and the C. But we'll get more in depth in that in a minute. Okay, so all we've done is talk about ratios and proportions, and now we're going to use it. Any questions so far? Oh, bye. This one says the ratio of the measures of the angles in triangle NAP is 2, 3, 4. Okay, so let's first label my triangle. Ooh, keep forgetting to change over to the pencil. NAP. It doesn't matter which one you label which. Remember when we do examples like this, it might not necessarily be to scale. So don't freak out if you're like, oh, well, this one looks like it's smaller, but ends up being bigger. Like this is just a guide for us. It doesn't need to be perfect. Now, it was important for us to label that because now I have to use the idea that this is triangle NAP and it goes 2 to 3 to 4. The first ones listed go together. So angle N and then that 2 of the ratio go together. A, the middle one, and then 3, the middle one go together. And then P, the last one, and then 4, the last one go together. Now we did this kind of briefly back in like, I think unit 1 or 3 or something like that with like supplementary angles. And we would say, okay, an angle and its supplement, and we'd say like X and like X plus something or X times something. We're going to do that same idea here, but now that we've learned about ratios, we know that this is how they're like related to each other. So it's like 2 to 3 to 4. They all have like a common factor in them. So it's like 2 times something, 3 times something, 4 times that same something. But we talked about simplified ratios before. So 2 to 3 to 4 is simplified. So we took out the greatest common factor, and we're going to treat the greatest common factor as like X here because we don't know what it is. So like for n, it goes with the 2. So I'm going to write 2x for n because I don't know what I'm multiplying by 2 and by 3 and by 4, but it's the same number each time. So for a, I'm going to write 3x. And then for p, I'm going to write 4x. 2 goes with n, 3 goes with a, 4 goes with p, and it's the same number as being multiplied by all of them. We just don't know what that is yet. We can pretty easily figure out what it is though. If these are all angles, what do all of the angles inside of a triangle add up to be? Anyone know?
$180.
Good. I heard a couple of you say it, which means that we were all thinking it. 180. I know it's been a while since we did just triangles, but we remember all the angles in a triangle sum to 180. So we're going to go write a nice clean equation over here where we do 2x plus 3x plus 4x equals 180. You can do it in whatever order you want. It's all being added, so it's commutative property. And then once we have this equation ready, we're going to start solving for x. So I'm going to do 2 plus 3 is 4, or sorry, 2 plus 3 is 5, and then 5 plus 4 is 9. 9x equals 180. Divide by 9 on both sides, x equals 20. Okay, so once I find XO, I'm not done. The question says, use algebra to find the measures of the angles. We just found X, we didn't find any measures of the angle, so let's find the measures of the angles. And I'm actually gonna list them over here. Off to the side, I'm gonna say measure of angle N is something, measure of angle A is something, measure of angle P is something. Now we're gonna replace 20 in for X for all of these, so we can do like 2 times 20. 2 times 20 is going to be 40. So angle N is 40. Same thing for angle A. It's 3x, so I'm going to do 3 times 20, and then 3 times 20 is going to be 60. So go write 60 for angle A. I'll stop jumping around in a second, I promise. And then the last one is P, which is going to be 4 times 20, which is 80. That's what my answer is, what all of my angles are when you plug in for X. Now, if you're like, how do I know if I'm right? We can check our work here. We can't always check our work, but we can check our work here. So I like to do that if I can. We want to see if 40 plus 60 plus 80 equals 180. So I'm kind of writing that down. I'm thinking question mark. Well, 40 plus 60 is 100, and 100 plus 80 is 180. So yeah, that works. That's good. Check mark. All good. Okay, any questions on that? Okay. All right, I guess I brought up cross multiply a little too early because we're going to talk about that a little bit more in depth right here. This says cross products property. The minute we see cross products property, you guys might be like, all right, I'm already tapped out. I don't really know what this means, and I can't really do much about it. Product, though, remember that happens when you multiply two things together. So the product is when you do something times something else, that gives you the product. So this is just telling us about, I'm sorry guys, my like emails and texts are like blowing up, and I don't know about you, but I get like so distracted every time that happens. So, okay. I can't stop the emails from popping up, but trying to focus. I lost my words there for a second. Okay, cross products property in words. This means in a proportion, the product of the extremes equals the product of the means. We get all bent out of shape sometimes because we're like, I don't know what's extreme. I don't know what means are. You don't have to really know that much. The extremes mean like the smallest thing, which is always in that like top left-hand spot, the A, and then the biggest number, which is always in that bottom right-hand spot. The or the means are the ones in the middle, which are B and C. When we cross multiply, it's just that we multiply across. So B and C get multiplied together and A and D get multiplied together. You've done this before. I know you have. I know we've tried to do it in the past. We've done AD equals BC before, but now we're just like solving problems using this and doing it a little bit more intense. I know you did this back in Algebra 1. So it gave it to us in words. You don't need to know the words. It gave us to it in symbols, which makes a little bit more sense in my brain. The only other thing I want to bring up is that the denominators, B and D, cannot equal 0, or else we'd have like undefined numbers, which would be a problem. And then it gives us an example. It says if 4 over 10 equals 6 over 15, then you can multiply again 4 and 15 and then 6 and 10. And they should equal each other. We're going to be doing this often to solve for a variable. So that's what the first problem we see here is. We're going to solve the proportion t plus 4 over 8 equals t over 3. We're going to solve that. Now, we're going to cross multiply, and I'm just going to tell you be very careful up front. Okay, so let's do it. Okay, when I say be careful, it means don't just multiply anything until we write down the first step. So I've got 8 and t. Okay, that's pretty easy. So I can write 8 times t. Oh, that's really messy. You might be like, Ms. White, why didn't you just write 8t? Because I'm trying to prove a point. So let me prove my point, and then I'll write it however I want. And then now I'm going to multiply 3 and t plus 4. Now I'm going to argue you should write it out like this, 3 times t plus 4. Because if you're not careful, you might just multiply the 3 and the 4 together and forget to multiply the 3 by t. Or you might multiply the 3 and the t together because you're like, oh, okay, I know those go first, but then you might forget to distribute to the 4. So this is how I just play it safe, and I'm very careful. Once I cross multiply, this is an Algebra 1 equation. 8 times t is 8t, 3 times t is 3t, and then 3 times 4 is 12. I'm going to minus 3t from both sides. So I get, ooh, I ran out of space. All right, over here. I get 5t equals 12. And then we divide by 5 to get t by itself. And you know what? This is going to be okay. We're just going to leave it as a fraction, 12 over 5. T equals 12 over 5. If we were to plug that in, we would get the same answer on both sides of the equation. We don't often get fractions or decimals, but it's okay if we do. So I liked to put an example of one in here just so you could see that it's okay that it happens. Okay, any questions so far? Okay, the next two problems look a lot more difficult than they are. They look like long word problems, but we're just going to piece out the numbers that matter to us, and then we're just going to set up a proportion and then solve. So Byron is measuring plants in a field for a science project. Of the first 25 plants he measures, 15 of them are smaller than 1.5 feet. Okay, so he has a total of 25 and 15 of them are smaller than 1.5 feet. If I can help it, I like my proportion of the biggest, the total on the bottom, and then the like more specific number on top. So I'm going to make it go 25 on the bottom and then 15 on top. So 15 is the specific number of plants that are smaller than 1 foot. And then the denominator 25 is just all of the plants he's measured. So now I'm kind of thinking in the next sentence, I want to hopefully find either a number that's like specifically plants that are smaller than 1 foot high or a total number. So it says, if there are 4,000 plants in the field, predict the total number of plants smaller than 1 foot in height. Now I use total in that last part, but I hope that doesn't confuse us. Plants that are smaller than 1 foot in height, that goes on top. That goes with my 15. So I'm going to put an X there. I don't know. I have to predict, and I don't know how many plants are smaller than 1 foot. However, I do know the total number of plants is 4,000. So X out of 4,000 should be the same ratio as 15 out of 25. Is everyone okay with that? Okay. Once we write our proportion, then we just cross multiply to solve. 15 times 4,000 and then 25 times X. 25 times X equals 15 times 4,000, which I'm going to do off to the side. 60,000. So there's 4 zeros behind that, 60,000. Now last step is to get x by itself. So I'm going to divide by 25. So 60,000 divided by 25 is 2,400 or 2,400 plants. So if there's a total of 4,000 plants in the field and our proportion, our ratio is true for the 25 that we measured and all of them, we're going to predict that there are 2,400 plants that are smaller than a foot in height. How are we doing with that? Everyone okay? Any thoughts, any concerns? Okay, well, I'm gonna assume that's a no. Okay, and the next problem is very similar. At this time, it gives us a ratio. It doesn't say out of the total, these are the ones that we care about. This one's talking about birth rates. So it's saying in 2007, the rate of births in Ohio compared to the births in Indiana were approximately 5-3. So 5/3. Again, I told you I don't really like it when it's written like this, so I'm going to immediately write it like an up and down fraction. We have to read the sentence carefully. So it said births in Ohio compared to the births in Indiana. The number that goes first goes with the first state. So 5 births in Ohio, there were 3 births in Indiana. So we've got the Ohio on top and the Indiana on the bottom. In 2007, you guys were a couple years old, I think. I asked the kids last class because I was like, oh my God, were you guys born in 2007? I guess you're a little bit older than that. So in a few years, if I don't change this worksheet, we'll have kids that were born that year doing this problem. So that's kind of cool. Now it says, okay, there were 148,821 babies born in Ohio. And then it asks approximately how many Indiana babies were born. So we don't know how many Indiana babies were born, but we do know there were 148,821 Ohio babies born. Now this one's a little bit different than the last one because I don't have total on bottom and then a specific one. These are two like very distinct different things. And I just am differentiating by putting Ohio all on the top and Indiana all on the bottom. Anybody have a question on how I set up my proportion? If you flip anything too wrong at any point, you'll get a different answer than me at the end. So if you don't understand how I did this, just make sure to let me know. Because once we set it up, now we're just going to cross multiply and find x. So 5 times x is 5x, and then 3 times 148,821 gives me 40. Numbers are hard today. 446,463. And then divide that number by 5, and it gets me 89,292.6. Now, babies are like full babies. You can't be a baby. You can't have 0.6 of a baby and be good to go. If a baby is born, it is a full baby. It's done. So we are not going to round up when it's like a whole living being like that. That baby's not born yet. That 0.6 is not done cooking yet. So we've got to keep him. We can't include that baby in the count. So we're going to leave it here. We're going to say this number of babies were born in Indiana. All right. Cool. Questions, thoughts, comments? Wow, you guys are quiet today. It's been a long time since we've done online lessons, so it's kind of weird that I'm teaching you guys online, but we've had so many day 5s online that I keep missing you guys online, but I'd rather be in person, so we'll just deal with this as we do. All right, the next box says conversions you need to know. By the time we take a test or a quiz, we need to know these. Some of these you should know just from being in chemistry. So like you guys should be doing like centis and millis and kilos in chemistry. Until then, let's just keep using the sheet. That's why I gave it to you. But there are some that like we should just know off the top of our head, right? Like we should know yards and feet. We should know miles and feet. We should know hours and minutes and seconds and minutes. And then pounds and tons just aren't that hard. So we should also know those. You will eventually have to know these. So if I ask you, you should know like centi is 100 of 1, and then a kilo is 1,000. But for right now, we'll just use this. The reason we're doing conversions, and I like doing this because you guys do this in chemistry too, so it's kind of cross-curricular. The reason we do this is because if I have a proportion or if I have a ratio that's not the same units, it doesn't count as a ratio. So like 5 meters to 250 centimeters, like we're not speaking the same language on top and bottom. Those are 2 different units, and I need them to both be 1 unit in order for this to make sense. So in order for this to make sense, we have to get rid of both of the labels. If you remember on the front, it said no labels, and these should actually go in very evenly with each other. So they should just cross the labels out when we multiply to get them to be the same ratio, if that makes sense. So let's do this first example. It says we've got 5 meters over 250 centimeters. So I see right here, this says meters and centimeters. Okay, so 1 meter is equal to 100 centimeters. Let's go over here and do that. When I was taught this, we did like a little like railroad essentially where we just do conversions like this. I don't know how your chemistry teachers do it. So if it's like times and then you do a fraction beside it, I don't care. But I'm just going to do it the way I'm used to doing it. I like to put the labels in first. So I know centimeters needs to go on top. So it crosses off with the centimeters on the bottom. And then the meters need to go on bottom. So it crosses off with the meters on top. So all the units should cancel. Now there should be numbers that go with it. If you look above, it says 1 meter has 100 centimeters. So 100 centimeters goes on top. I'm sorry. Now you're allowed to do one of 2 things. So I'll do one method on this problem and I'll do the second method on the other one. You're allowed to just multiply the ones on top. We do not cross multiply here because there's no equal sign. You only cross multiply when there's an equal sign. When there's no equal sign, you just multiply the tops together and then the bottoms together. So I do 5 times 100 for 500, and then I do 250 times 1, which is just 250. All my units canceled, so I don't need to do those. The last step though is this needs to be a simplified fraction. So I need to simplify this as much as possible. Off the top of my head, I see that they both have a 0, so I'm going to cross off that 0. So I'm left with 50 over 25. I know those at least have a factor of 5, but I think it has a factor of more. So I'm going to try 50 divided by 25. Oh, it does divide evenly. That gives me 2 over 1. Now in real life, we could just say 2, but this is a ratio. So I don't want just 2 by itself. I want a 2 to 1 ratio. And so we can write it in a colon form or a fraction form, but you need the 1 there to show that it's a ratio. So this one we put our units in, we got rid of our uncommon units, and then we just multiplied and then simplified. The next one I'm going to simplify before I multiply, okay? So this one's feet into yards. If you scroll up, we see that in 1 yard, there are 3 feet. Okay, again, I'm going to make sure my units are on opposite sides, yards and feet. In 1 yard, there are 3 feet. Now, if you wanted to do it like we just did before, you would multiply the tops and the bottoms together and then simplify after that. I personally, though, like to simplify now if I can. So I have 15 and 4. Can't simplify those. Oh, I'm sorry. But I do have 15 and 3. And I have a common factor between those two. 3 works. So 15 divided by 3 is 5, and then 3 divided by 3 is 1. That now gives me 5 and 1 multiplied together on the top, and 4 and 1 to multiply together on the bottom. So that's going to be 5 over 4. And again, you can write it as a colon instead. Here's the first 2 in case you missed anything. Or if you're watching later on YouTube, you can pause and make sure that you understand this. We're going to try 3 and 4. So if you're ahead of me and ready to try it, go ahead and try it on your own. I'll join you in a second. All right, if you're ready to join me, I'm jumping over there now. Feel like we were always waiting for you. Thank you for your patience. I've got inches and feet now. That's actually one I know pretty commonly. Inches go on bottom, so the inches cross out, feet go on top. I wrote 1 ahead of time. I didn't plan to, but we know 1 foot, foot's bigger, and there are 12 inches in 1 foot. If you forgot that, I did say 30 feet is 36 inches, and you could divide 3 from both of those. Or if you just forgot and want to rewrite at the top, I'd write 1 foot is 12 inches at the top of your paper. That's a common one, I think you know, but in case you don't, let's write it up there. Inches crossed out, feet crossed out. Now, before I simplify, I can't do anything with 15 and 2, but I can do something with 15 and 12. They both have a common factor of 3. So I have 4 and 5. Now, sometimes people are like, oh, well, what about the 2 and the 4? No. Those are on the same line. Those don't get to cross out. So those do not get that chance. They stay on the same line. And so I'm just going to multiply now 5 times 1 on top and then 2 times 4 on the bottom. It gives me a ratio of 5 to 8, which again, we can write as a fraction or as a colon. All right. Similarly, the last one is kilometers to meters. Kilometers to meters, however you want to say it. The km is going to go on the bottom and the m is going to go on top, so they cross each other out. And then if I don't remember this off the top of my head, I can just scroll up a little bit. 1 kilometer is equal to 1,000 meters. So I'm going to put 1 on the bottom for the km and then 1,000 on top for the meters. The easiest thing to cancel out here is just some zeros. So 900 has 2 zeros and 1,000 has 3 zeros. So I can cross out 2 of them. And then that just leaves me 10 times 10 on top and then 9 times 1 on the bottom. So I've got 100 over 9. And that's actually as simple as it gets. So I can write that as a fraction or with a colon. Both of those are ratios. Those are the last 2 if you need to look at those again. Okay, any questions so far? All right, I am going to need some help on the next problem. So the next problem looks like there's a lot of work. There's not as much work as it looks like we need. It's just rewriting the fractions. So if we have this proportion, A over B equals C over D. Remember when we cross multiply, we get A times D, and then we get B times C. So now all we're doing is just kind of like mixing up the proportion and writing it so that at the end, when we multiply, we get A times D equals B times C. So this one, it looks like I've got B over A. So it looks like I switched this. So in order to make sure I've got A and D going together when I cross multiply, I need to make sure if A's down here, D's up there. So I'm going to put D on top. Similarly, if B's on top here, across from it needs to be C, so C goes on bottom. So when I flipped A and B, I also need to flip D and C in order for this to be equivalent or, you know, the same proportions. Everyone okay with that? All right, well, can someone help me on the next one? If I have A over C, what should that equal? What over what?
BD.
Good. B on top, D on bottom. Very good, Nolan. A and D go together, B and C go together. Perfect. And then one more like this. Now I've got C over A. How would I rewrite this?
DB.
DB. Awesome. Thank you, Nolan. D on top, B on bottom. Very good. I hope most of you were just saying it to your muted microphones at home. So hopefully we all knew what those were pretty simply. We're going to skip this second to last one. We're going to go do the last one first because we've been on kind of on our proportion game, and then we'll do that second to last one, and then we're done for today. All right, so we've got this proportion at the end, cross multiply and solve. So take a second, start solving. I'll join you in a minute. Anyone waiting for me to join? Here I come. 6 times x, and then 4 times 3x minus 12. And I'm gonna literally write it like that. 4 times 3x minus 12. Make sure to just distribute carefully. So 6x equals 12x minus 48. And then I'm gonna minus 12x from both sides to get negative 6x equals negative 48. And then divide by negative 6 from both sides, so x equals 8. All right. Any questions or concerns on that one? Pretty self-explanatory. The only thing is a common mistake is if you don't multiply the 4 by both of the 3x and the 12. So make sure you distribute that, be really careful. All right, the very, very last one we're gonna do is similar to the triangle one we did on the first page. It says the measures of the angles in a quadrilateral are in the extended ratio of 3 to 4 to 5 to 6. Find the measures of the angles, okay? I'm gonna draw a quadrilateral. It doesn't have to look like anything good. It doesn't have to be to scale. You don't have to label it and be like, oh, well, this doesn't look like 3 times something and this is 6 times. I don't care. We're trying our best. So it's in the extended ratio of that. I don't give you any side lengths, so I'm just gonna make sure I just go around the shape like this. When it's an extended ratio, it means that we've simplified it. So I'm gonna do 3 times x and 4 times x and 5 times x and 6 times x to represent that from this simplified radical, we had taken out a GCF. That GCF is x. So I've got 3x and 4x and 5x and 6x. Again, this does not look to scale. Yours doesn't have to either. But I do need to remember what all the angles in a quadrilateral add up to be so I can solve this. Does anyone know?
360.
Very good, Donna, 360. So all of these added together equal 360. And you can do them in whatever order you want. 3x plus 4x plus 5x plus 6x equals 360. And then just like the triangle problem, solve for x, and then we plug in x to find all of our angles. 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 6 is 18x. And then 360 divided by 18, I believe is 20. Yes, 20. Now it did not ask for x, it asked for the angles. So just because I put an x doesn't mean I'm done. Now I've got to do 3 times 20 and 4 times 20 and 5 times 20 and 6 times 20. I don't have the actual angle names, but I will just probably go over here and just write 3 times 20 and say that's 60 degrees. And I'll do 4 times 20, which is 80 degrees. And then I'll do 5 times 20, which is 100 degrees. And then last 6 times 20 is 120 degrees. And so these are all my answers. Again, we can check our work by doing 60 plus 80 plus 100 plus 120. I can just look at it and know that 100 plus 80 is 180. And then 60 plus 120 is 180. And 2 times 180 is 360. So I should be good. I'm good to go. I checked my work. Check. Okay. I think that's all on our notes. Does anyone have any questions? I want to remind you that your homework is just a 1-pager, so make sure that you get that done. I'll stick around for a little bit if anyone has any questions, but that's class today. So you're welcome to go a few minutes early. Enjoy your day. I do not see you tomorrow, but I see you on Wednesday. So this homework is due on.
Thank you.
Bye, guys.
Thank you.
Thank you.
Thank you.